NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams.
The universe might be breaking the rules right before our eyes. Nobel Prize-winning astrophysicist Adam Riess warns that our entire understanding of how the universe expands could be flawed. Prepare for strange galaxies, dark matter mysteries, and signs of a big mistake in what we knew. JWST, bizarre cosmic behavior. Adam Riess and his team looked at something called the Hubble constant, which is a measure of how fast the universe is expanding. And here's where it gets dicey. There's a big difference between the new measurements of the universe's expansion rate and the older ones. They call this Hubble tension. It's not just a fancy scientific term, it's an actual problem that's been confusing scientists for a while now. Could this mean our understanding of the universe is flawed? What comes next could change everything. Then comes the JWST, the new telescope that was supposed to solve all our problems. Well, instead of solving things, it's just made everything weirder. JWST took a bunch of new measurements, and these confirmed the older, conflicting numbers. So now scientists are forced to admit the universe isn't expanding the way we thought it was, and it's not just a measurement error. It might mean that there's something fundamental we're missing about how the universe actually works. It's like looking at a puzzle that's mostly put together, and then suddenly realizing that some of the pieces are actually from a completely different puzzle, or maybe the whole thing was upside down the entire time. Riess and other scientists are now left trying to figure out if our understanding of the universe has been fundamentally flawed all along. One of the biggest mysteries that JWST is poking at is the idea of dark matter. If dark matter doesn't exist, and some new data seems to point that way, it would be a massive problem. Dark matter has been the way scientists explain why galaxies move the way they do. It's like trying to balance a chair with one leg missing. Dark matter was supposed to be the leg that made it all make sense, even if we couldn't see it. Without it, everything is wobbly again, and we're not sure why. Quantum physics also adds to the confusion, throwing a wrench in the works. Quantum theory tells us that everything at a tiny scale behaves unpredictably, and nothing is ever certain. Combine that with an ever-changing universe, and it's no wonder we can't figure out what's really going on. All of this confusion doesn't mean that science has failed. It's actually the opposite. It means that science is working. When things don't fit, it means we're on the verge of discovering something new. The whole point of science is to test what we think we know. And right now, the universe is giving us a pretty solid reason to go back to the drawing board. There's a lot we don't know, but that's exciting because it means there's so much more to discover. In the meantime, we're left staring at the stars, wondering what's next. Whatever comes out of this, it's bound to change everything we thought we knew about our place in the cosmos. And if you're into mysteries, it doesn't get much bigger than this. The James Webb Space Telescope has brought a level of precision and clarity that we haven't had before. And with it comes the realization that our previous models of the universe might need a major overhaul. Theories that once seemed to make sense are now being questioned. The idea of a perfectly expanding universe, smooth and consistent, is now under scrutiny as more evidence shows irregularities and strange behaviors. In astronomy, there was always a concept of dark ages, a period when the universe was dark before the first stars started to shine. Scientists were eager to find direct evidence of this period using JWST, but here we are without much evidence to prove the existence of this cosmic blackout period. Instead, we're finding galaxies that seem to have formed sooner than should have been possible. The galaxies are larger, more developed, and simply put, should not be there according to our current understanding. The existence of dark matter is another big question mark. For years, we've relied on dark matter to make sense of what we observe in galaxies. The way galaxies spin, the way gravity holds everything together, none of it made sense without an invisible form of matter accounting for it. But now, JWST is challenging even that. If dark matter isn't real, then what's holding galaxies together? What's responsible for the strange, inexplicable movements we've seen out in space? There's a term scientists use called isotropy, which refers to the uniformity of the universe. That if you look in any direction, you should see basically the same thing. But JWST is providing us data that doesn't match up with that. There are regions that look different, and galaxies that seem to behave differently from others. If isotropy is a myth, then every assumption we've made about cosmology needs to be reevaluated. It's not just one mistake in a formula, it's the whole way we think about the universe. The idea of regional currents within the universe is also gaining traction. Think of it like a lava lamp. Different blobs moving at different speeds, bumping into each other, sometimes merging, sometimes breaking apart. The universe might be expanding in certain areas while contracting in others, with different physical laws applying in different regions. It's an unsettling idea because it suggests that our universe isn't one uniform thing, but a patchwork of different realities, each behaving in its own way. It's also possible that we're only seeing a tiny part of a much larger universe, a universe that might have multiple dimensions beyond the three spatial dimensions and one-time dimension we're familiar with. The idea of a multiverse, once considered fringe science, is becoming more and more plausible. The anomalies we see could be the result of interactions with other universes or dimensions, and the JWST might just be giving us a peek behind the curtain. The discovery of structures in galaxies that seem far too mature for their age is a significant puzzle. According to the Standard Model, galaxies form over billions of years, gradually growing as they pull in more matter. But JWST is showing us galaxies that seem to have formed almost immediately after the universe began. These galaxies are massive, fully formed, and look nothing like what our models predict they should look like. It's as if someone hit the fast-forward button on galaxy formation, and we have no idea why. The problem with dark matter gets even worse when we consider gravitational lensing, the effect where gravity bends light, allowing us to see objects that would otherwise be hidden. This effect is one of the key pieces of evidence for dark matter, but JWST is showing us gravitational lensing that doesn't fit with the expected distribution of dark matter. It's like the map we've been using to understand the cosmos is suddenly full of wrong turns and dead ends. The universe's strange behavior points us to vast, empty voids that challenge what we know. Voids in space challenge. Big Bang's uniformity. The uniformity of the cosmic microwave background radiation has also been called into question. This radiation, which is thought to be the afterglow of the Big Bang, was supposed to be evenly spread throughout the universe. But JWST is finding regions where this radiation is not as uniform as we thought. This challenges the idea that the universe began in a single, uniform explosion and has expanded evenly ever since. Another point of interest is the existence of voids. Vast, empty regions of space where there seems to be almost nothing. These voids don't make sense if the universe is supposed to be evenly filled with matter. JWST has been able to peer into these voids with greater detail than ever before, and what we're seeing doesn't fit our models. The existence of these massive empty spaces might suggest that the universe is far less homogeneous than we've believed, and it raises questions about how matter is distributed on the largest scales. In trying to piece together all this new information, scientists are beginning to wonder if our understanding of gravity itself might be flawed. Gravity is the force that holds galaxies together, dictates the movement of stars, and governs the expansion of the universe. But if dark matter doesn't exist, then our current understanding of gravity might be incomplete. Some researchers are even exploring alternative theories of gravity that could explain the strange behaviors we're seeing. All of this paints a picture of a universe that is far more complex, far more mysterious, and far more fascinating than we ever imagined. The discoveries made by JWST are not just minor tweaks to our understanding. They are forcing us to reconsider the very foundations of cosmology. Every new image, every new piece of data is a reminder that the universe still holds many secrets, and we are only just beginning to scratch the surface. The confusion, the questions, and the mysteries are not signs of failure. They are signs of progress. Science is not about having all the answers. It's about asking the right questions. And right now, we have more questions than ever before. The universe is challenging us, pushing us to think deeper, to question our assumptions, and to explore new possibilities. It's an exciting time for astronomy, and whatever answers we eventually find, they will undoubtedly reshape our understanding of the cosmos and our place within it. Scientists believe that constants like the speed of light or the force of gravity were exactly that, constant. But now it seems like there's a chance that these numbers aren't as unchanging as we assumed. Take the fine structure constant, for instance. It's all about how strong electromagnetic interactions are, and some observations suggest that it might have been different billions of years ago. Even a tiny change in these numbers is a big deal. It's like the universe is whispering that maybe it hasn't always played by the same rules. And this isn't just some wild theory with no backing. There are actual models that physicists are using to explore the idea that these constants might shift under certain conditions. Some theories even suggest that forces like gravity and electromagnetism might evolve as the universe itself grows and expands. Researchers are using data from things like exploding stars and cosmic background radiation to test these models. So far, it's all very tentative, but the hints are there. Maybe the universe isn't as fixed as we thought. Constants are called constants for a reason. They're supposed to be the reliable numbers that make the math of the universe work. If they're not constant, a whole lot of physics textbooks would need a rewrite. Plus, the tools we use to measure these things are incredibly precise. So any claim that the fundamental constants are changing has to meet a super high bar of evidence. No cutting corners here. Despite the controversy, scientists are pressing on with this research. Advances in technology, like next-level telescopes and super precise instruments, are making it possible to test these ideas better than ever before. Every new measurement, every peek into deep space, is like another piece of evidence for or against this idea. And if we do find out that the laws of physics are evolving, it's going to change the way we understand everything, from the smallest atom to the vastest galaxy. What's especially mind-blowing is that this idea might help us figure out a grand theory of everything. You've probably heard of string theory. It's one of the frameworks that tries to explain all the fundamental forces in one neat package. According to some versions of string theory, changes in constants could be linked to hidden dimensions or other phenomena we haven't discovered yet. It's a bit like finding out that there are more rooms in your house that you didn't even know existed, except instead of rooms, it's the whole dimensions of reality. Imagine the journey scientists are on as they explore this idea. To truly understand how the universe works, it isn't enough to just accept what we already know. That kind of thinking limits our perspective and keeps us from uncovering the deeper mysteries that might lie hidden. The scientists working on this have to question everything we've built our understanding on, even the most sacred laws of physics. It's a daunting task. How do you even begin to investigate whether something as fundamental as gravity has been different in the past? One way scientists approach this is by studying the light that comes from the furthest reaches of the cosmos. Light is like a messenger carrying information from the past, and the longer it's traveled, the further back in time it takes us. By examining the light from distant stars and galaxies, researchers can start to get a sense of what things might have been like billions of years ago. They look at how the light interacts with different substances on its journey, how it gets bent, absorbed, or shifted, and they try to match that with what we understand about the universe today. If they find something that doesn't fit, it could mean that some of the constants we take for granted might have been different back then. Imagine if you're looking at an ancient star and the data suggests that light wasn't moving at the speed we've always thought it did. That would be a huge deal because it would imply that one of the most basic parts of our understanding, the speed of light, might not be constant after all. And if that's up for debate, what else could be changing? Unusual galaxies and voids lead us to quasars, which might show the universe isn't following the rules. Quasars suggest evolving universe rules. The study of distant quasars is also shedding light on the possibility of changing constants. Quasars are incredibly bright and distant objects powered by massive black holes at the centers of galaxies. Because they're so far away, the light we see from them has traveled for billions of years. When that light passes through clouds of gas on its journey to us, it leaves behind a signature that scientists can study. By comparing these signatures from different points in time, researchers have found subtle hints that the fine structure constant might have been slightly different long ago. It's not conclusive yet, but it's enough to make people sit up and take notice. There's a lot of debate around this topic, as you'd expect. Some scientists argue that the variations being detected are simply errors or the result of interference. Maybe we don't have our instruments calibrated quite right, or maybe there are phenomena we don't yet understand that are affecting our observations. The universe is incredibly complex, and it's easy to get misleading signals. That's why this kind of work is slow, cautious, and requires a lot of cross-checking and verification. When you're dealing with the fundamental laws of reality, you can't afford to jump to conclusions. The idea that these constants could evolve is incredibly compelling. It makes the universe feel less like a static machine and more like a living entity, something that's constantly changing and growing, with laws that adapt to different stages of its development. If this is true, it could also mean that other universes, if they exist, might operate under completely different sets of rules. Maybe there are universes out there where gravity is stronger, where light moves slower, where atoms hold together in different ways. It's the kind of idea that makes you realize just how vast and mysterious everything truly is. Technological advances are playing a huge role in this research. Newer, more powerful telescopes allow scientists to look further into the past, gathering data that just wasn't accessible before. Instruments that can measure tiny shifts in light or changes in gravitational waves are pushing the boundaries of what we can observe. And with each new piece of data, we either get a bit closer to confirming the idea of changing constants, or we refine our theories to explain why they stay the same. It's a constant back and forth process, but that's how science progresses, by questioning, testing, and refining. If we eventually confirm that the constants are evolving, it could also give us new insights into the early universe and what led to the conditions we see today. There's still so much we don't understand about the Big Bang, why it happened, what came before, and how the universe's initial conditions set the stage for everything that followed. If the constants weren't the same, it might explain some of the puzzles we've been struggling with, like why the universe appears to be expanding at an accelerating rate. Maybe dark energy, that mysterious force pushing the universe apart, is related to a change in one of the fundamental constants over time. The possibility of evolving physical laws also ties into the search for a unified theory of everything. Right now, we have different sets of rules for the very large, general relativity, and the very small, quantum mechanics, and they don't quite match up. String theory and other approaches have been trying to bridge that gap, but it's possible that understanding how constants might evolve is a key piece of the puzzle. If we can figure out why and how these constants change, it could help us unify our understanding of all the forces at play. This journey into the unknown is one of the most exciting parts of being human. We're creatures driven by curiosity, by the need to understand the world around us, and by the desire to explore beyond what we know. Whether it's looking out into the furthest reaches of space or delving into the deepest mysteries of physics, the quest to understand the universe is a testament to our ability to question, to wonder, and to seek out the truth, no matter how elusive it may be. Something unusual is definitely happening out there in the universe. Maybe the rules we thought we knew are more like guidelines, always shifting, always evolving. And if that's the case, then we're just getting started in our quest to understand the true nature of everything around us. Is the universe actually different in every direction, or have we just been wrong all along? Leave your opinion in the comments below, and don't forget to like and subscribe for more.